Which one do I use? Right now, you want to say something? Yeah. I have a D, I've got a VI, I've got an A, and I'm looking for T. So let's use that one. D equals VIT plus 1/2 AT squared. And the beauty here is that because VI in the Y direction is 0, this piece goes away. So we're going to have 40 equals 1/2 9.8 T squared. Because we called down positive, both of these are going to be positive. So we can solve this thing. We're going to get 40 equals half times 9.8 is going to be 4.9. I've got a T squared. I'm going to divide by 4.9. I'm going to divide by 4.9. I'm going to get 40 divided by 4.9 is 8.16. That's going to be equal to T squared. And then the thing you want to not forget is to square root this value now to find T. So what this is going to tell you is that it would take the ball 2.86 seconds to drop vertically 40 meters only under the effects of gravity. Yes. It was the square root of 8.16, and so that's going to go on forever. So I rounded it to 2.86. And now the important thing to remember here is that, the only universal piece is time. So if the vertical time was 2.86 seconds to drop, that's going to be the amount of time that this thing can travel horizontally. Because at that point, it's going to be at our catcher. So the time now in the x direction is going to be 2.86 seconds. What else do we know about the horizontal portion of the problem? Sorry? We know the VI. The VI is 20. What else do we know? VF is not 0. Is there anything acting on the ball horizontally? After the kick, the ball is just going to fly through the air. So acceleration in the x direction has to be always in the x direction, the acceleration is 0. There's nothing slowing it down. It will move at whatever depth it throws. I can throw some textbooks around again to show you to do this again. There's nothing that's going to slow it down horizontally in a meaningful way while the ball's on the way to the ground. Yes, now you know, but what about the wind? Yes, I know. The wind does things. We've seen it. We've all watched soccer. We've all watched football. The kick goes and the wind blows it back. Yes, I get that, but that becomes infinitely more complicated. We're not there yet. Acceleration in the horizontal direction is 0. So what that means is the VI is just V the whole time. So if there's no acceleration and we're looking for D, the horizontal distance away from the building that the catcher has to stand, this portion of the problem is a constant velocity problem. This is just going to be V equals D over T, and I want to solve for D, so D is going to be V times T. So then D is going to equal the 20 meters per second times 2.86 seconds. So where does our catcher have to stand? Well, the catcher's got to stand. This value here is 57.2 meters, or just over half a football field away from the bottom of the building. So this is going to be your procedure here. Let's do another one. I'll do one more example for you, and then I'll leave you to play with it. We'll make it more interesting in a couple days. Are there any questions about this before I move on to the next one? Okay, here we go. Another scenario. We'll take it a 10-meter building this time. We're going to put someone back on top of the building. There's a ball. Let's put someone a reasonable distance. So a 10-meter building, that's a 3-story building. That's like Abby, standing on the top of Abby Senior. That's going to be about 10 meters. Let's put someone over here. Let's say that this person is standing 25 meters away. You know the height of the building on which you're standing. You're able to ballpark that the person that you're trying to get the ball to is about 25 meters away. The question here is going to be, how fast do you kick the ball? Given these parameters. And so for any projectile problem, the beginning is the same. We're going to separate these things out into a horizontal and a vertical portion of the problem. And we're going to write down everything we know. So what do we know? Give me something you know. Which distance? We know both. We know distance in the x direction. We know distance in the y direction. Distance in the x direction is going to be 25. Distance in the y direction is going to be 10. And by telling me that distance in the y direction is 10, what are you assuming, Brad? You've just made an assumption. By telling me that dy is 10 and not negative 10. That means down is positive. You got to make sure that you record that assumption somewhere. You need to be aware of the assumptions that you're making. If you call this 10, what else needs to be positive? Acceleration due to gravity. A is equal to 9.8. That is also true. You want them to catch it at the feet. Meters per second squared. What else do we know? There's one more piece of information we know. Very important piece of information. VIY is equal to 0. If the ball's not moving, the problem is doable. If the problem is, well, I mean, it's doable if the ball is moving to start, but it becomes a little bit more interesting. And the only thing we can find here is the time it takes to drop. That's going to be equal to the time taken over here. And so that's going to lead us to what is Vx? This is what we're looking for. So we can use this information to find the time. Once we know this time, we can use this to find Vx. So let's go ahead and do it. This is going to use this equation. D equals VIT plus 1/2 AT squared. And at this stage, it's not a big deal to use this equation because VIY is 0. If VIY is not 0, now you're using the quadratic formula to solve this thing, which some of you don't know yet. But VIY is 0, so this is going to be 0. And now I can fill in the rest of our information. D is going to be 10. That's going to be equal to 1/2 times 9.8 times t squared. These are both positive because Brad assumed that down was positive. I'm cool with that. So it's going to be 10 equals 1/2 of 9.8 is 4.9. T squared, divide by 4.9, divide by 4.9. For the sake of time, I'm going to give you these values. And yes, Raina, this is rounded. 2.041. is going to equal t squared. Be really deliberate about your notation because you don't want t squared, you want t, and so we're going to square root this. We'll take the square root of that number. And we're going to get 1.43 is what I'm going to round that to. Nope, that's just t, not t squared. I square rooted it, and the squared is gone. Okay, so this is the amount of time it takes for the ball to reach the ground. And now how far or how fast do you have to kick it if in that time you want it to get over here? So this time, the 1.43 seconds, is going to be this time over here, the 1.43 seconds. And now we want to find Vx. The horizontal portion is always going to be constant velocity, so there's no acceleration. So V is going to equal d over t. We don't need to rearrange it because that's what we're looking for. Yeah, Brad? Sorry? Yeah, give me the answer. 25 over 1.43 is? Let's call that 17.5 meters per second. So that is how fast you need to kick the ball. That's how fast the ball needs to be moving when it leaves your foot if you're going to get it to your friend on the ground 25 meters away. Questions, comments, concerns? Okay. We'll make it more interesting day after tomorrow. Tomorrow you're going to do a lab with dart guns. For the remainder of class today, I want you to take a look at these 6 questions. All of them. All of them.
Yeah, but I'm gonna do like
If, you know what, I'll shrink this down a little bit. The first 2 questions are the same, so let's say do question 1. We'll do 1 instead of 1 and 2. I'll get you to question 3, because 3 and 4 are exactly the same. And I'll get you to question 6. You know what, let's shrink it. Let's not do all. Let's do 1, 3, and 6. Because 1 and 2 are the same question. 3, 4, and 5 are all the same question. Oh, no. 5 is different. I want you to do 5 as well. 1, 3, 5, and 6. 4 questions instead of 6. Use this time. Get this done. Tomorrow we lab.